Good morning. In today's session, we are supposed to study about the different speed control methods of the three-phase induction motor. In previous session, we have seen about the three-phase induction motor, the construction of three-phase induction motor. We are making the three-phase induction motor by using the stator and the rotor. In our syllabus, we are supposed to study about two different types of three-phase induction motor. These are nothing but squirrel cage and the slip ring induction motor. When we will require higher starting torque, at that time we can use slip ring induction motor. And when there is not requirement of higher starting torque, we can use squirrel cage induction motor. And the construction of squirrel cage induction motor is simple as compared to the slip ring because there is no need of brushes and the slip rings. Then we have seen about the torque equations for the three-phase induction motor. Torque equations you will get T equal to S into K into R2 into E2 square upon R2 square plus S x2 square. Then we have seen about the equation for synchronous speed. You will get synchronous speed, that is nothing but capital N suffix small s. It means what? You will get N of S equal to 120 F upon P. F is nothing but the frequency and P number of pole. There will be the numericals on the synchronous speed, rotational speed. If they are not talking about any speed, that speed you are supposed to take as a capital N. It means what? Rotor speed. After that, there will be numericals on the torque equations. So here, when we will get the equations for torque and when you will get the equations for NS, at that time, you are having the relations between NS and the capital N. How? Because we are having the formula for slip. Slip is nothing but we can take slip will be the ratio of NS minus N upon NS. There is no need of video. Okay. So here we are taking slip equal to NS minus N upon NS. So here we have already seen the speed of three-phase induction motor will interrelated with the supply voltage. Which voltage we are giving, that will be related with that voltage. It will be related with frequency because we are having the formula where we can see synchronous speed will depend on the frequency and asynchronous speed will depend on frequency. In short, we can say the speed of three-phase induction motor will depend on the supply frequency. So here we can say instead of varying both, we can vary only supply voltage. That time also we can control the speed of three-phase induction motor. Then we have seen about the varying rotor resistance. Strength अच्छा है आज. Please keep that strength because in last week and in this week also, only 2 to 3 guys are present. So please try to attend each and every class. Okay. So here we are saying we can vary the rotor resistance also because when we have seen the torque equations at that time, already we have seen we will get the rotor resistance in numerator as well as denominator. So here we can vary these things and we can control the speed of three-phase induction motor. First method already we have seen. We will revise this and we will go to second and third. So here, when we are supposed to control the speed of three-phase induction motor, at that time we are having our first method, that is nothing but varying supply voltage and varying supply frequency. So the best method to control the speed of three-phase induction motor is we can vary its supply voltage or we can vary supply frequency. So in short, we can keep that ratio V by F as a constant. Because if we are varying the voltage, if we are varying voltage higher and if we are minimizing the frequency, it means what? We are supposed to keep that V by F ratio constant. So we can keep that ratio constant and we can maintain the speed of three-phase induction motor. So here we can say it will uses the power electronic circuit in which we will get the frequency and voltage controller. You can say VFO. It means what? We can control the voltage and frequency. So we can say that as a VFO, voltage frequency oscillator, where we are controlling its frequency as well as voltage. So you will get V by F ratio constant and we can regulate its speed of three-phase induction motor. So by regulating speed, what we will get? Here we will get the maximum torque that will become constant. So you can see here already we have seen the torque equation with the speed. So here we will get the waveform like this. So here if we are increasing the time, if we are increasing the time, what will happen with frequency? Frequency is nothing but it is the reciprocal of time. So we can say here frequency is decreasing. So as we are decreasing the frequency and we are increasing the supply voltage, we can see here, you will get the starting torque. That will be this. You can say that will be the starting torque. So here you will get when we are increasing the value of supply voltage and decreasing the value of frequency, at that time you will get the V by F ratio constant, and with this you will get the increase in a speed. If you see, we will get the increment in a speed. So we can see here we will get the V by F ratio constant, and as you can regulate the speed, and as we are regulating, we are maintaining its speed of three-phase induction motor, you will get maximum torque value. So here we are saying about three-phase induction motor. At that time we will suppose to maintain V by F ratio constant, and as we are maintaining V by F ratio constant, here we are saying flux will be proportional with voltage and it will be inversely proportional with frequency. So if we are putting this ratio constant, flux will become constant. We can regulate the flux. We can maintain value which will require by maintaining this ratio. And as torque is proportional with the V by F ratio. So here we will get the speed that will depend on the frequency. How? Synchronous speed you will get 120 F upon T. Please mute yourself, Suyesh. So here, when we are maintaining the value of V by F ratio constant, we can put the value of flux, or you can take here phi. If you are taking phi constant, if we will get the maximum value of torque by maintaining, by regulating the speed, because we are taking V by F ratio, we are taking this value constant. So here we can regulate its speed, and if we are not changing any value of V by F, and if we are changing the value of load at that time, how we can do? We can change the speed, because here we are saying we are supposed to maintain V by F ratio constant, and as we are putting the V by F ratio constant, torque is depending on that. So we can get the value of torque constant. So we will get here torque constant by maintaining the V by F ratio constant. So here we are supposed to vary supply voltage, and in that way we are supposed to vary supply frequency. If we are changing both values, numerator as well as denominator, and you are doing the changes vice versa, मतलब न्यूमरेटर का वैल्यू बढ़ा रहे हो तो डिनोमिनेटर का डिक्रीज कर रहे हो, तो क्या होगा? You will get that ratio constant, or you are doing the vice versa. It means what? Only you are supposed to vary this value, but जो ratio आ रहा है उन दोनों का V by F का, numerator और denominator का, you are supposed to maintain that ratio constant. So we can do this by using the VFO. It means what? here we can use variable control and variable frequency and voltage controller. So here when we are supposed to use VFO at that time, this is the frequency converter. So here we are supposed to change the value of voltage. If you see this, when we are giving the power supply, this L1, L2, L3, these are nothing but when we are giving the power supply. You can take RYB or you can take any, the names which we are giving the power supply. To whom we are giving? We are giving to the stator and it will give to the rotor. So here we are having the, this is the squirrel gauge induction motor. This induction motor is nothing but the squirrel gauge induction motor. So here when we are giving the three-phase power supply to the three-phase induction motor, at that time we are supposed to vary the frequency. So we can vary the frequency by using the frequency converter. And here we are supposed to vary the supply voltage. So we can see here we can use the circuit diagram like this to vary the voltage and vary the frequency of the three-phase induction motor. So here when we are giving the power supply at that time, here we guys are using the transformer to get the power. So here when we will get the line power at that time, we can use here fuse. If you see at our home, we are using the power supply. So here there is a fuse. So we can, if we are making the disconnect, we will not get the electricity. So here when we are supposed to use the, when we are supposed to change the voltage and frequency of three-phase induction motor, at that time we can use voltage frequency controller to change that value. And how we are changing? We are using this device to change that value. But how we will get the power supply? We will get the power supply from the transformer. That's why we are supposed to draw diagram like this. So here this is the practical diagram. There is no need to draw this in the exam. If there is a question like explain the supply voltage and supply frequency variation method to control speed of three-phase induction motor, at that time you are supposed to draw this diagram. Here we are giving the power supply. You can, instead of this, you can directly write here we are giving the power supply. You can write here transformer, or you can write here the power supply. We are giving that power supply to the variable frequency controller. This is the main block, because here by using this we are supposed to change the frequency as well as the supply voltage. So here you will get the variable frequency power which we are supposed to give here. You can write here AC motor, or you can write here three-phase induction motor. And here you will get the speed that can be controlled by varying the frequency and varying the voltage. Or you can draw this line diagram for the varying supply voltage and a supply frequency in the three-phase induction motor. So here we can control the frequency by controlling the frequency or the voltage of three-phase induction motor. Now we can see about the remaining two methods. These are nothing but varying rotor resistance or varying supply voltage. So firstly we will see about varying rotor resistance. So here now we are supposed to vary the rotor resistance, because when we have seen the equation for torque, what equations we will get? You will get torque equal to K into S into R2 into E2 square upon R2 square plus S X2 square. So here you can see we can vary the torque by varying the value of resistance, and by varying the torque, if you see we are having the equations torque का जो अभी equations बोला उसके आगे if you are writing for the speed you will get into 3 upon 2 pi ns. because torque equations, if you see, we are taking the K value. K is nothing but constant. We are taking K equal to 3 upon 2 pi ns. So in short, you can say speed and resistance are interconnected. It means what? They are having the value that will be related with each other. So we can say here, if we are supposed to vary the speed of three-phase induction motor, you can vary rotor resistance. Because if you see, for wound rotor, we can use varying rotor resistance to vary the speed. Because if there is a speed is decreasing, if you observe our this waveform, the same waveform. Here we are taking on the y-axis time and on the x-axis we are taking the speed. You can observe the same waveform here. So here if you see, if we are taking the same waveform here on the y-axis we are taking the time, on x-axis we are taking the speed. So here we are saying, if we are decreasing the frequency, if we are decreasing the frequency, at that time you will get increase in a speed. But here we are supposed to see about the how the effect of rotor resistance on a speed. So if you see here, this is the value of resistance R1 which is less as compared to the R2, where you will get the maximum speed. So we can say the value of speed is inversely proportional with the resistance. So if you are increasing the rotor resistance, you can say its speed is decreasing. So we can regulate the speed of three-phase induction motor by regulating the value of rotor resistance. And here you will get torque value that will be the constant, because by regulating the value of rotor resistance and by regulating the value of speed, we can regulate the value of torque. So we can say here the speed at which we will get the maximum torque. You will get here maximum torque here. So we can say here there will be the changes in speed. So we can change the speed by regulating, by changing the value of rotor resistance. If we are decreasing the value of resistance, if we are decreasing the value of resistance, you will get increment in a speed. And L is nothing but no load, and S means synchronous speed. So we can say we can regulate the value of speed of the three-phase induction motor by varying the rotor resistance. But this type of speed control method is having some disadvantages, like there is a power loss that will be reduces the efficiency of three-phase induction motor. And also here you will require large speed regulations, because to increase the speed you are supposed to reduce the resistance. So we can say it is having the disadvantages like a large speed regulations. So here we can see about the third method. Here also we are supposed to control the speed of three-phase induction motor by using the by controlling the rotor resistance, and here we are supposed to control rotor voltage. So here if you see practically three-phase induction motor will be like this. So here if you see its construction, we are saying this will having the rotor winding. Here is a we are having the slip rings. Rotor core will look like this. So here we are supposed to vary its rotor resistance. At that time we are saying if we are supposed to increase its speed, we are supposed to reduce its value of resistance. So here when we are supposed to use the rotor resistance method, at that time this is having the disadvantage, like here it will reduces its efficiency and it will require large speed regulation. So we can see another method, that is nothing but the third one, where only we are supposed to vary the supply voltage. So here if we are increasing the supply voltage, if we are increasing supply voltage, you will get increment in a speed. Here also we are taking the same graph. When we are supposed to see about the different speed control method, there will be the same diagram. On the y-axis, you are supposed to take time. And if time is increasing, you can see time, frequency is the reciprocal of time. So you can say frequency is decreasing. Another, on y-axis, on x-axis, you are supposed to take the speed, and here only you are supposed to study about the supply voltage. So here you are supposed to vary the voltage. So here, if you see, value of voltage is decreasing when we are increasing the time. It means what? Here, if we are increasing the time, it means what? Frequency is decreasing. At that time, you will get changes in a voltage. How? Value of voltage is decreasing. And if value of voltage is increasing, if you see V1 is high, V1 is having highest value as compared to the V3. So when we are increasing the value of supply voltage, you can see you will get increment in a speed. This is the speed for V1. This is the speed nr2 for the V2. And when you are studying about the speed characteristics for the value of V3, you can see you will get the speed that will be nr3. So you can see here you will get the value of speed we can regulate by varying the supply voltage. And how it is proportional? It is directly proportional. So if you are increasing the value of supply voltage, you can increase the value of speed. So here you will get the value of torque that can be get constant. So if we are changing the value of supply voltage, there will be change in a torque, because torque is directly proportional with E2 square. So if we are changing the voltage, there will be the maximum torque changes, and the speed at which you will get maximum torque. You can say you will get maximum torque when we are having the value of reactance that will be equal to RR upon slip. So we can say there you will get the speed that will be the constant, because here we will get the value of torque that is maximum. And this is the simple method. Here only we are supposed to use voltage controller. There is no need of VFO. There is no need of changing the rotor resistance. Here only we are supposed to vary the supply voltage. So here only we can use the electronic circuit that can be called as a voltage controller, because here only we are supposed to control voltage. So we can use here simple electronic circuit that can be used as a voltage controller, and it can be suitable for fan type load, but it is also having the disadvantage like there is a large speed regulations like a varying rotor resistance. So here we have finished about the different speed control method that can be used to vary the speed of three-phase induction motor. Now we are supposed to study about the different applications of the three-phase induction motor. So here if you see about the three-phase induction motors applications for the squirrel cage or the slip ring, you can take applications in a squirrel cage like grinder, centrifugal pumps, blower, fans, etc. And for the slip ring induction motor, you can take applications like elevators, lifts, compressor, etc. Here we have finished about three-phase induction motor. If anyone is facing any issue, you can ask me. Okay. So here we have finished our today's session. Now you guys can leave now. Thank you.